Alright, let's talk about the development of the periodic table. So, at the end of the 1700s, scientists only knew about 100 elements, so it wasn't really that hard to keep track of them. Um, the properties and everything was fairly easy just to remember 30 different elements and their properties. That's what most chemists were expected to do. Um, but over the next 100 years or so, we used new experimental techniques, something that you've actually seen, line spectra. So remember, when you vaporize an element, it produces its own unique line spectra. So remember with the spectroscopes, you looked at the, I think it was potassium chloride and sodium chloride, and saw the difference in the light that was created by those. So over the next 100 years or so, using those techniques, scientists doubled the amount of elements that they knew. So as the list grew, it got harder and harder to remember all of those elements' names, properties, and how they kind of fit together. So along came J.W. Dobereiner. He was a German chemist in the early 1800s. So he started grouping elements into sets of three, which he called triads. What he'd do is he'd take three elements that had pretty similar properties and organize them in order of, actually, I don't know the order of he used, but he organized them so that the middle element had properties that were about the average of the first and last. So many of the properties of the middle element were pretty much approximate averages. So like maybe he was using density and he realized, okay, well, density kind of fits that pattern, but well, look, melting point also fits this pattern. Ionization energy also fits its pattern. So it was a pretty big breakthrough, and it was the first real organization scheme that we had for elements. And so first thing we had was triads. A little bit later, 1865, actually quite a bit later, J.A.R. Newlands, an English chemist, came along. So at this time, there were about 62 elements, and he organized them by increasing atomic mass, just like you did in that periodic card game thing, that lab you did earlier. So he noticed that when he did this, that the properties of every eighth element were similar. So the properties of the first element and the properties of the ninth element and the properties of the second and the 10th element were pretty similar. So he called this pattern the law of octaves, after the 8 notes on the musical scale. He must have been interested in music. So it was a great idea, and actually, as you know, atomic mass is a good way of organizing the elements if that's all you know at the time. So unfortunately, he never was really taken seriously because he related the theory to music. It's kind of interesting. They're like, oh, well, he's one of those music people. And so no one really took him seriously, even though he was right a full 4 years before Mendeleev. So, Dmitri Mendeleev, the guy that's given credit for the current, or starting the periodic table, he was a Russian, and he had a pretty awesome beard. If you look in the book, there's a pretty cool picture of him. And so in 1869, he and another chemist, Lothar Meyer, who was a German chemist, published pretty much an identical scheme for classifying the elements. Both of them ordered the elements by increasing atomic mass, just like Newlands had 4 years earlier, and they probably were aware of his research, and that's probably how they decided to use atomic mass. Even though no one was giving him credit, people were reading the research. So Mendeleev got more credit than Lothar Meyer because he was better at demonstrating its value. So instead of just saying, well, here's a great idea and throwing it out to the world, he was better at communicating that idea to his colleagues and to the scientific world. So being able to communicate in science is just as important as being able to figure something out, if you want to get credit anyway. So, and to a lesser extent, he was also like a couple of months earlier. So that helped him a little bit too. So it pays to be able to communicate in science, and it pays to be first. So why is Mendeleev given so much credit? I mean, after all, he only really took Newland's research and like ran with it. Um, so did he do anything really that good? Yeah, he did. So one of the things that Mendeleev did that was pretty groundbreaking was that sometimes he broke the order of increasing atomic mass to keep the elements in the columns with similar properties. So he thought that the atomic masses were actually wrong. He's like, well, if we recalculate these atomic masses, we'll figure out that these two are really in the right order, but we just don't know the correct atomic mass. He was wrong about that, as you guys know. Sometimes the periodic table breaks the order of increasing atomic mass, but he did keep them in columns which kept the similar properties, which actually turned out to be closer to the current periodic table than it would have been if he'd kept them in order. One of the really important things that he did is he also predicted the existence of many elements that were unknown at the time. So, based on his classification scheme, there were some gaps. He was like, well, there should be something that fits here. According to everything else, I've got, a little gap here. There should be something that fits. And he actually predicted the existence of some elements that we know today. One of the famous ones was germanium. Didn't get named rushenium, even though he was Russian, and he predicted its existence quite a bit earlier. That would have been kind of cool. But anyway, and he actually predicted their properties as well. So he said, well, this element will be found and is going to have these properties. So he was pretty brave to go out and say that. He was a pretty brave guy. And turns out he was right. So this is actually one of Mendeleev's later tables, the one that you're going to work with today in the lab, and not the lab, in the worksheet, is an earlier version. But take a second, pause this video, and compare this periodic table that Mendeleev made around 1871 to the current periodic table. So you probably notice that there's some really pretty striking similarities and some pretty big differences as well. So later on, there was an English chemist, H.G.J. Moseley. I don't know why these guys had so many initials and not like real names, just maybe the current style at the time. So he was born in 1887 and died in 1997. Tragically, he actually died in the Gallipoli Battle of World War I. So he was working with Rutherford as a doctoral student, working on his PhD in chemistry, when they, mostly Moseley is given credit for this, discovered atomic number. You can read about that. It's not really that important to me that you know how he discovered atomic number, but he did. So this helped scientists realize that not atomic mass, but atomic number was the real pattern that Mendeleev had found. So when they compared Mendeleev's periodic tables to atomic number, it fit perfectly. Remember that Mendeleev said that atomic masses were incorrect? Well, he was wrong on that, like I said earlier, but the atomic number fit his pattern and fit the current periodic table very well. So that led to our current periodic table and periodic law. So periodic law says that when elements are arranged in order of increasing atomic number, their physical and chemical properties show a periodic pattern. So you guys know from that straw activity that those patterns include atomic radius, ion size, ionization energy, electron affinity, electronegativity, density, melting point, and many more. So that tells you how the periodic table was developed. You should be able to do most of the assignments in the Chapter 5 folder. Good luck. I'll see you next week. And if you have any questions, feel free to, leave blanks and I will help you when I return.